Okay. Let us find the next topic, expected value. How can we find? Can you see the whiteboard?
Yeah, ma'am.
Okay.
Is our classes
Because for
recording now?
further topics, we need it. Can you see now?
Okay, okay. Yeah, ma'am. Yeah, ma'am.
Okay, all right.
Ma'am, is our classes recording now?
Yes, exactly. Yeah,
Okay.
I have on the recording. Okay.
Okay.
So let us learn expected value. So expected value is denoted by EX, and which is equal to summation X into PX, and where X is discrete random variable and Px is correspond sorry Px is probability for each value of x. Okay. So let us understand this by using an example. Okay.
Okay.
So let us take an example when we toss three coins together. Okay. Like fine. Mm. If three coins tossed together, then outcomes outcomes we can get three head on all coins, three tails on all, two hats in a such way means two hats on first, and like this also means we are finding all possible. Okay.
Yeah, ma'am.
And with one hat we can have two tails on last two, and head on first and tail tail on first, head on second, and tail on third. And similarly we can get this also. So these are all possible outcomes. Okay, we have.
Okay.
So let us find means value, let x be a random variable define, or you can say denote the number of hand. Then values of x of x are 0 for no head, for one head, for two heads, and maximum we can have three heads.
Three.
Okay. So now let us form a probability distribution table. Okay, let us construct it. Probability distribution means we have a table in which we have values and corresponding probability. Okay. So here we have
Mm.
x, and we have here px corresponding frequency. And how can we find for each value? Let us find if x is equal to 0, 1, 2, and 3. px at x is px. When x is equal to 0 means for formula of probability, that is equal to favorable number of outcomes over total number of outcomes. So for no had, how many outcomes we have? Only one.
One.
So its probability will be 1 upon 8, number of favorable outcomes upon total number of outcomes. This is the formula to find probability. Now let us find for one had. For one had, how many outcomes we have? 3. Got it?
Correct. Uh,
So this will become 3 by 8. And for two had also we have, three outcomes.
I think
For two
1
had,
by 9 right now. There are 9 outcomes now, ma'am. There is 9 outcomes, so we have to 1 by 8 and 3 by 9, I think. 1
no,
by
we have, we have 8, 2, 3, 8,
okay, okay, okay,
5 plus
okay,
3, 8. Okay, we have total 8 only.
okay,
And for three hats, we have only one outcome, this one only. Okay. So now let us find 1 upon 8 for that. So to construct this table of probability distribution, we need to write values of x and corresponding frequency. Like we have 0, 1, 2 and 3
2,
values of x and corresponding probability. We have 1 by 8, 3 by 8, again 3 by 8 and 1 by 8. Okay. Now we need to find expected value. Now let us find it.
uh,
Expected value ex is equal to summation x into px, means sum of all values, product of x and
okay,
px. Yes. So now let us find. So first value of x is 0 and its probability is 1 by 8. Next value we have here 1
1,
and its probability is 3 by 8. Next is 2 into 3 by 8 again, and plus 3 into 1 by 8.
1 by 8.
So now let us find, let us simplify. So 3 by 8 plus 6 by 8 plus 3 by 8. So what will we have? 12 by 8, right?
0.1.
So
0, yeah, 12.
3 by 2. Or you can write 1.5,
Uh,
which is 1.5. This is expected value for the given experiment. Okay. In this experiment, a coin three times or three coins together. Okay. We can take this is the same condition. Okay. We'll get the same outcome for that if we toss a coin three times or
uh,
three coins toss together. Okay.
uh,
So now you got the meaning of this expected value. So
uh,
how can we find variance, mean, standard deviation with the help of expected value? Okay, what is the relation between them? Let us find it. So mean is mean, variance, and standard deviation in the terms of expected value. Let us learn it. Mean, we are taking population mean, okay, which is equal to, because we are taking sum of means product of all values of x and like px. So population mean, mu is equal to expect itself of expected value, and variance sigma square, that is equal to summation x square px minus summation x px. This is value of expected, I mean this is expected value, okay,
Okay.
whole square.
Hmm.
And standard deviation just square root of variance. Standard deviation sigma, that is equal to square root of the summation x square into px
Minus
minus summation x
summation
px, or you can write here px also instead of
x.
summation
Okay.
x px. Okay. So
Okay.
now let us find these all values for this given experiment.
Okay.
So first of all, we need to construct table to find variance and standard deviation. We need this also, okay? Because
Okay.
we have this already, and but we need to find this. Okay. So let us
Okay.
construct table
Okay.
for it. Equals expected value. So we can take this equal to like 1.5, or you can take 3 by 2. Okay.
Okay.
We have x and px. We need to find first x square and xpx, and then x square px.
Okay.
So value of x, we have 0, 1,
1, 2,
2, and 3.
2.
So px means the corresponding probability 1 by 8, 3 by 8, 3 by 8.
3 by 3
Okay.
by 1 by 8.
And again 1 by 8. Okay. So now let us put the values. So we are 1 by 8, 3 by
3 by
8,
8.
3 by 8,
Yeah.
and 1 by
1 by 8.
8. X square is 0, 1, 4, and 9. XPX, obviously first term we have 0, and next term we have 3 by 8.
8.
Again next term we
1
have
by
6 by 8 and 3 by 8. You got it?
8. Yeah, yeah, ma'am.
Or you,
Okay, okay. Yeah,
or
ma'am.
you can write as also, so that we can not confuse. First value is 0, next value is 3 by 8,
8,
Next value is 6 by 8 like this, or
6
you
by
can write 3 by 8.
8, 3 by
And
8.
now multiply px with x square. First value is 0. And next value we'll get obviously 3 by 8. And next we'll get 12 by 8 and 9 by 8.
6, 4 by 24, 24 by 8, I think.
See, we are multiplying these two values, then these two, and
Okay,
then
okay,
these
okay.
two, and this
Okay,
one.
okay, 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 okay. Got it, got it. Okay, right.
That's not a problem.
I was multiplying with the P of x equal to P of x.
So,
So, yeah.
this one we'll get here. Finally, 3 by 2, which, and here we can add them like 3 by 8 plus 12 by 8 and 9 by, sorry, 8, not 18. So we'll get 24 by 8, I think so. So 3 by 8
Okay,
and 12 by 8 and again 9 by 8. So obviously 24 by 8 and we'll get 3.
3, yeah.
So now let us find variance, because mean mu is equal to 1.5. We have already find expected value, and variance
This 3.
sigma square, that is equal to summation x square into px minus summation x px
X
whole
whole
square.
square.
Now let us simplify. We have this x square summation. This is summation
Yeah,
x square px. We have 3, and let us write this is summation x px is equal to 3 by 2.
3 by 2.
Now let us put value. This is 3 and minus 3 by 2 whole square. Yep. So 3 minus 9 by 4, and we'll get it uh, 12 minus 9 by 4 is finally 3 by 4. Okay, variance sigma square. You got it?
Yeah, 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 ma'am.
Okay. And now let us find standard deviation amount of variance, okay, to find standard deviation. We write in short standard deviation. Shall I use this standard deviation
Yeah,
SD?
ma'am.
It's
Yeah, ma'am.
square root of 3 by 4. And we can write it 3 root 3 by 2.
Ma'am,
Okay.
I have a small doubt. I mean, the previous slide.
Pardon?
Yeah, I have a small question, ma'am. In the previous slide, I will, if you just go down, I will just show you.
Just a second, I'm just using. Give me a moment.
Yeah, yeah, okay, okay.
Now you can tell me what you want to ask.
I have a small question in the previous slide. If you come down and ask
Okay.
me.
Yes, sure, sure. Which one? Here?
Yeah, yeah, ma'am. In the last, I mean, sigma square, 12 minus 9, how we got the 12, ma'am? 3 4 is the 12. We
Okay,
have,
okay. I'm telling you. Okay, okay. I'm telling you. Actually, 3 square is 9, and 2 square, we have whole square here. You got it?
okay, okay.
Because
Yeah,
summation
yeah,
x
ma'am.
into px, we have 3 by 2. So obviously we are doing here square. Okay. So we'll get here
Okay,
3
ma'am.
square is 9 and 2 square is this. And just we are
4. Yeah.
simplifying this as a fraction. We are using here fraction means simplification. I'm telling you. So you have here 3 minus 9 by 4. Do you remember in fraction, just to make like same denominator, just we multiply and divide by this number. Okay.
Okay.
So
Okay, ma'am.
we made, yeah, we made it here 4 as a denominator and
Okay.
3 into 4. That is why.
Uh,
Okay. Yeah.
okay. Okay. Okay, ma'am. Then got it.
Now you got it.
Yeah, yeah, ma'am.
It's
Got it.
okay.
Yeah.
So sigma square. So after simplification, we have sigma square variance is equal to 3 by 4 we have. Okay. Now we are finding, to find standard deviation, it's a square root. Okay. So we have standard deviation this. Or you can find decimal also of root 3. Okay.
Okay.
And this is, if you take in decimal form, then just write value of root 3 1.732 and divided by 2.
2.
So we'll get here 0.86. 866 you have, so just by rounding off, or you can write 0.87.
Oh, okay, ma'am.
You got it? Yeah. So
Right,
I'm just checking your this lecture.
ma'am.
7th week lecture, right? Lecture 7.
Lecture 7. Yeah, ma'am. Yeah, ma'am.
Okay. And to learn this PDF of probability density function, we need to learn gamma value also. Okay.
Yeah, ma'am.
We have learned expected value, and see, initially probability density function is defined in the terms of gamma function. I'll tell you. Okay. How can you find? And do you
Okay, okay.
remember factorial value? Do you remember factorial value?
No, no, ma'am. I don't remember it, ma'am.
Okay, it's okay. I'll make you remember. Okay, because to learn gamma function or gamma value, we need to know factorial value also. That is why I'm asking to you.
Okay, okay.
So let us learn factorial value,
Okay,
because this is, means, so as we have less time, so we can learn in this time period this factorial value.
okay,
So
okay,
tomorrow we'll start this gamma, mean how to find gamma value and this probability density function. Okay,
okay, ma'am. Okay,
it is so easy factorial value. Uh, Factorial value means, or let n be a natural number, then factorial value of n can be defined as, this is symbol like explanation. Okay, this symbol denote factorial value. What it means, just multiply n with, just subtract 1 from n into n minus 2 into 3 into 2 into 1. What it mean, let us understand by using some values. Okay, so if we are
okay,
using n is equal to 4, so factorial 4 means, just write here 4 into 3 into 2 into 1, so its value is 24. Similarly, let us find some more values, like We are finding factorial value of 3, which is 3 into 2 into 1, which is 6. Similarly, if we are finding factorial 5, which is 5 into 4 into 3 into 2 into 1. Okay,
Now 120.
you got it? This
Yeah,
is the
yeah, ma'am.
factorial
Got
value.
it.
You can find for any. Okay, and we
Okay.
have some means shortcut tricks. When you have in means fractional form, then how can you solve it? For example, if you have factorial 10 over factorial 5, so how can you solve? You can't cut directly, okay? You can't cut as like this, okay? Because
Okay, ma'am.
factorial 10 is 10 into 9 into like 8, 7, 6, 5 into 4 into 3 into 2 into 1. And factorial 5, 5 into 4 into 3 into 2 into 1. Okay, so you can see here in factorial 10, we have here factorial 5 itself. Okay, so just expand this
Okay.
means instead of expanding entire, we'll expand till here
10.
10 into 9 into 8 into 7 into 6, and just right after that factorial 5 here. Or don't expand this
Yeah, ma'am.
denominator. Just now cut directly. Okay, just expand till here. Okay, now just
Yeah, ma'am.
multiply rest off
Okay.
and you can find the value. Now, got it?
Oh,
Or shall I
okay.
explain you again? You got it?
No, no, got it. Got it, ma'am.
All right. So, in this way, you can find factorial value of any. Okay.
Okay, ma'am.
So,
Okay, ma'am.
I'll teach you tomorrow this gamma value. How can you find? Because initially you have this probability density
Yeah,
function
ma'am.
in terms of gamma values. And
Yeah, ma'am.
next topic, expected value. We have done variance. We have done this. Okay.
Yeah, ma'am.
And
Yeah,
after
ma'am.
that, we need to do, okay,
Yeah.
okay, we'll do pairwise comparison and all, and sample comparison problems we have. So we'll do further. Okay.
Okay, ma'am. Okay, ma'am.
So we'll
Thank you, ma'am.
start on time tomorrow at 5 p.m. Okay, so that we can cover
Okay, ma'am.
maximum. Okay. All
Yeah,
right.
yeah, ma'am. Yeah, ma'am. Thank you so much, ma'am.